Every single day, millions of people paste their work in ChatGPT, Claude, and Gemini. They ask it to summarize a report, check facts, write an email, and review code. And then they hit send. No second look. Full trust. Now, I'm not here to tell you that AI is bad. It's not. I use it every day. But there is one number, one benchmark that should tell you how confidently you should hit that send button. And that number is hiding in plain sight, buried inside the system cards of every AI lab. Most people have never seen it. Today, we are going to look at it directly. Introducing SimpleQA. So what is SimpleQ? It was created by OpenAI in late 2024. It's a benchmark, a standardized test of 4,326 short factual questions. Things like, who wrote a specific book? What year did an event happen? What's the capital of a particular region? No multiple choice, no hints, just can the model give you a specific correct answer? Google then built on this, creating SimpleQA Verified, a refined version of 1,000 questions, independently tracked by Epoch AI, one of the most rigorous AI research organization in the world. The questions span politics, science and technology, art, sports, geography, music, and history. The grading system has three outcomes: correct, incorrect, and this is the most important one, not attempted. A model that says, I don't know, will actually score better than the one which will give you a confident but wrong answer. Because confident wrong answers are exactly what hallucination is. Simple QA doesn't test creativity. It doesn't test reasoning. It tests one thing. Does the model know facts? And does it know when it doesn't know? Now, the moment you came for, let's look at the actual score from Epoch AI's independently run Simple QA Leaderboard. We are going to look at this in two layers. First, the models that people actually use every day. The default free tier and standard models. GPT 5.2, the default model in ChatGPT for most users, scores approximately 38% on simple QA. That means on a simple factual question, it gets the answer wrong or doesn't attempt it 62% of the time. Gemini 2.5 Pro and Gemini 3 Flash, Google's widely deployed everyday model, scores around 56% and 67% respectively. Claude Sonnet 4.6, Anthropic's standard workhorse model, performs at around 29%, which is lowest in the category. We'll talk about why is that so and why it is still better to use Claude for most of the use cases. Now let's move to the premier tier. The model the AI labs claim they are the best. GPT-5, GPT 5.1, 5.4 Pro and O3 Mini, OpenAI's latest flagship model, scores significantly higher. Depending on the evaluation run, we see scores around 48% to 53%, a meaningful improvement. Gemini 3, Google's top model, also performs strongly, particularly on grounded tasks. It often reaches 72% and or above on Simple QA Verified. Claude Opus 4.2 and 4.6, Anthropic's most capable model, perform at 42 to 46%. Still an improvement over Sonnet 4.6. But here is where it gets counterintuitive. The model with the most advanced reasoning, like O3 from OpenAI and Opus from Claude, actually score lower on simple QA than standard models. Why? Because when a model reasons through many steps before answering, each step is a chance to hallucinate something. The longer the chain, the higher the compounding error. It's not a bug, it's mathematics. So now the practical question. If the premium models are better, why aren't we using them? The answer is cost. Let me show you the gap. Claude Sonnet 4.6 everyday model costs $3 per million input tokens and $15 per million output tokens. Claude Opus 4.6, the flagship model, cost $15 input and $75 output. That's a 5x price difference. GPT 5.4, the regular model, cost around $2.5 per input and $15 per output for short context, and $5 input and $22.5 output for larger context. But GPT 5.4 Pro, the flagship model, will cost $30 input and $180 output for even shorter context. Even Gemini's model, which are not as expensive, that start with Gemini 3.1 Pro, cost around $2 per input and $12 per output. Whereas the regular Gemini 3 Flash model, which everyday users use, costs around a $1 input and a $3 output. The result in almost every real world deployment, every internal tool, every customer chatbot, every bulk summarization pipeline, teams are running on cheaper models, which means they are unknowingly operating at 30 to 50% factual accuracy on raw knowledge context. This is not a criticism, it's an economic reality. But this means the human checkpoints matter more than ever. So, what do we do about this? This is where a new engineering discipline is silently emerging. It's called Evals, or short for evaluations. In traditional software, QA engineers write test cases. Input goes in, output comes out, test passes or fails. Deterministic, predictable. With AI, it's different. The same input can give 10 different outputs. You can't just write a unit test. You need an evaluation framework, a system that tests your AI the same way simple QA tests the AI models, with structured question answer pairs with a grading mechanism. Here is how modern evals work in practice. Step 1. You build a golden dataset, a curated set of inputs and their expected correct outcomes, specific to your product and domain, not generic, yours. Step 2. You run AI against that dataset automatically. Every time something changes, every prompt upgrade, and every model update. Step 3. You grade the outputs. This is where it gets interesting. For factual questions, grading is simple, right or wrong. For subjective tasks like summaries or recommendations, you use a technique called LLM as a judge, using a rubric you define. Step 4. You monitor in production because what user actually asks is always different from what you tested. So evals are not a one-time thing. They are a continuous pipeline. Tools like Deep Eval, Langsmith, Langfuse, and AISI's AI Inspect framework have made this easily possible. You don't need a research team now. All you need is an engineering discipline. So if you are a QA engineer today, or a software engineer, or an AI builder, or product manager, and an entrepreneur, your job is evolving now. It's no longer just about building and testing software, it's about testing AI. And the engineers who understand evals, hallucination benchmarks, and how to build structured evaluation pipelines, they are going to be the most valuable people in every AI product team for the next decade. Where AI intelligence fails, human intelligence starts. And now you know where to start. This is Anand Arora and you are watching Decode by Anand.